Hey there, students. I wanted to give an example as we're moving into the world of hypothesis testing. And in this example, I'm using problem number 8 from homework number 10. So this is from chapter 8, section 1. And this is a problem in which they ask for the test statistic for a proportion, an examination of population proportion. And one of the things I wanted to illustrate is that often at this time, students are starting to confuse two different items. One is the test statistic, and the other is the critical value. So let's read the problem and talk about the two, the difference between the two, and I'll show how to use StatCrunch to get the test statistic. The problem says that there's a claim. Most adults would erase all of their personal information online if they could. A software firm survey of 590 randomly selected adults shows that 62% of them would erase all of their personal information online if they could. So there's a claim that most adults, meaning greater than 50%, and then there's a sample taken and a survey done in which 62% said they would. So this is a study about population proportion, because we're just saying what proportion of the population would say yes to the question. So this is a proportion stat. And they're asking us to find the test statistic. So a test statistic is a little different from a critical value. A critical value is the distribution score you would need to get to reach a particular confidence level. And so a critical value uses whether you want to have a 95% surety or 99% sure, uses the confidence level and the kind of distribution you're performing, proportion, mean distribution, t-stat, chi-squared stat. So a critical value is the distribution score you need to hit a particular confidence level, and it doesn't say anything about what you got in your sample. In fact, you can see what the critical value for a survey might be before you ever even take the survey. And when you're getting a critical value, you typically just go to the calculator for that distribution, like go to the t-stat calculator, and then enter the information about your confidence level and how many people you're going to survey, and figure out what critical value you would need from a sample in order to meet that confidence level. So they're asking in this case for the test statistic. For the test statistic, that's the distribution score you got based on your sample. Like in this case, it's a proportion study. So the question would be, what would the distribution score be on a proportion distribution, which will be a z distribution, when you have 590 people and 62% of them make a particular claim, in this case that they would erase all their data. So they want this, the test statistic is the distribution score for this particular sample, for 62% out of 590 on a proportion distribution. So having tried to clarify the difference between those two, what I would do is I would open StatCrunch, which I have here on the right, and I'm going to use the sample described where they give me a summary. So I would go to Stat, and since this is a proportion distribution, I would go to Proportion Stats. They have one sample and with summary. And then that gives me this tool. So what we're going to do is give the number of successes and the number of observations. Well, I know the number of observations in my sample was 590. But they didn't tell me how many of them said yes. They said what portion of them said yes, 62%. And the StatCrunch calculator wants the actual number of successes. So what we would do is determine how many out of 590 would be 62%. So I have the calculator up here to help us do that. So to do that, you multiply 590 times the decimal percentage, which is 0.62, to see what 62% of 590 turns out to be. 365.8, so this needs to be a number of successes. We'll round that off to the nearest whole number of 366. So 366 successes out of 590 would be 62%. So once you've put those in, we then want to look at the hypothesis test that we're matching against. And this is a test for the claim that most adults would erase their data. Most adults just means more than half. So we would leave the null hypothesis that the proportion is equal to 50%. That's the default. And then we would change the alternative hypothesis to be that P was greater than 50% because that means most would erase their data. So we put in the number of successes, which may need to be calculated depending on whether the problem gives you the percentage or gives you the actual value of yeses, the number of observations, and we set the hypothesis test to match the claim, and then we can hit compute. So this box of results for a hypothesis test, the thing we're looking for, the test statistic, as I said, that's the distribution score. And this is a z distribution because it's a proportion test. So the test statistic for a z distribution is the z stat, which is given here. They want that to 2 decimal places, so it looks like I grab the first 2 and I have to round the 4 up to a 5, which I will do. And that's what they want. So again, the test statistic on a z distribution is referred to in StatCrunch as the z-stat, and so you would perform the proportion hypothesis test, putting in information from your sample, and then the z-stat will be provided by StatCrunch. So hope that helps. Keep up the hard work, and I'll see you when I see you.